Drawings, continuation of yesterday, just more of these special things. Remember, for a triangle, especially if it's a regular, by the way, the first thing that you should really highlight is this is a regular polygon. Let it go. All right. It's frozen. That's why I said that. Okay. You don't see it on the screen, but in the class screen, I was frozen. Kind of like doing this if I do reference the screen up there too. 4 different things that you could do for this triangle. Half base times height, grade school. Then I told you your world expanded now. You're no longer kids, you're young adults. And you could now have, well, I don't know if anyone looked at it in this class. I know one person last hour did Huron's formula, which I stated again. I forgot to move that video from third quarter to our thing yesterday if you wanted to see it again. And then that's when all 3 sides are given. Half apothem times perimeter if it's a regular polygon. And I almost couldn't, just like I couldn't think of a name, I almost couldn't think of the 4th one, but it just came up. 1/2 AB sine C, our trig unit, how that replaces half base times height. But what is this? What was our new word for yesterday? What's 6 root 2 called? 3, 2, 1, go. It's an apothem. So they're trying to get you maybe to use apothem times perimeter. So probably one thing I should do is draw all the what are actually called the radii, because what I could do is draw a circle that this triangle is inscribed in, and those will be the radii of that circle. The reason we want to do that, well, actually, I'm kind of ignoring our stuff that we learned about regular polygons. We really could say this radius bisects this angle here. Then I could go back to what is the measure of this big angle? Well, then it's that n minus 2 times 180 formula, right, everyone? But then I did something different. A full circle is 360, so this is 120. And then since this is 120, this is 60. By the way, I have a new thing my pen's doing. It's a lot of fun. It's actually getting worse, my pen. So it's really getting harder to write with, and I don't know why. But anyway, that looks okay. So far, so good. All right. So that's a 60, and then we got a 90 there. So this little side is a 30. All right. So we're going to stick with the half apothem times perimeter. We have the apothem. We need the perimeter. All right. So this is the 30-degree side. So that is A. Just listen to me. So then what's the 60-degree side? It is A times, say it, 3, 2, 1, go. Square root of 3. But A happens to be 6 root 2, so it's 6 root 2 times root 3. Right? That's what you have to have the ability to do. A root 3, 2A, you got to have that memorized. That is a whole unit. And then we moved into trig with that and then exercise those ratios like a million times. And again, here we go, second hour. I don't care that you hate me. This is why when you don't do your homework, you cause your own failures because you still don't know this. And if you still don't know this, that is 100% on your shoulders. Don't have any parents call me or anything about that, about this class being unfair. This is why I've been a jerk all year long. And it needs to be said more in second hour than it does in the first. All right, so again, take this to heart the rest of your mathematical and any other class career. You are the one that is in charge of your destiny. Nobody else. By the way, root 2 times root 3 is root 6. And that's why we bring these things back. It's nice to remind those that did do that. Okay, yeah, I feel good about that and can do that. By the way, 6 root 6 plus 6 root 6 is 12 root 6. Since this is regular, I have my perimeter. All right? So it does a couple things. From the apothem, I can find the length of that side. So I'm going to go ahead and do half apothem times perimeter. Half. The apothem was 6 root 2. I threw that radius right through that, but you could see that as the given. And then the perimeter is 3 12 root 6s. 12, 24, 36. All right, so we got some cleaning up to do on this one. First of all, I'll take half of 6, 3, and then do 3 times 36. 30, 60, 90, 96, 102, 108. But then it's root 2 times root 6, which is root 12. By the way, what's the square root of 12? A number. What times what equals 12? 3, 2, 1, go. 4 and 3, not 2 and 6. No one said 2 and 6. What's the square root of 4? 2. So this is, let's say it's the square root of 12. Square root of 4 is 2, so that's 216. Root 3 stuck in jail, that's the exact. Of course, the approximate, you can go from there. So again, it's not always, but it always kills me. My CAT students are notorious for this. They are notorious non-homework doing charlatan bums. All right, so when I try to do this stuff and say, well, we learned this, well, I didn't because I don't do my homework, then everything is brand new. We have to go all the way backwards, and I'm not. I can't facilitate those that can't help themselves. Can't. I'm done. All right, but it does for those that, are just doing their work and things are struggling to remember. Hopefully it does come back really quick. It could only come back if it was there in the beginning, though. All right, and then this one, I think I did do problems like this. I'll speed it up and do no more of this negative rant, which is called a diatribe if you want to put some vocab down. All right, now we have to get an apothem for this. Oh, by the way, I did want to go back to this. Did you know that we could actually do half base times height and we would get the same answer? Because this actually, in a regular triangle, this actually does represent the height if I connect the apothem to this radius. So what is this radius? Well, the radius is double 6 root 2, right? 30. You're gone! I just heard that noise. All right, yep, give me that thing. Did you hear it? I'm not hearing that noise like 37 times during a 50-minute lesson. Not going to do it. All right, so 6 root 2, double that is 12 root 2. So this height is actually 18 root 2. Are you with me? So you have options. You could have, I don't know, half apothem times perimeter. So that is actually true. It's really hard to write, so I know this is messy. This pen stinks, you know that. So a half, the base is 12 root 6. And now the height is 18. There, see that pen? Root 2. Wait a minute, does that give me the same answer? You can actually see that it does. Take 2 away from 12. 2 times 18 is 36. That would be 6. You would still have root 6 times root 2, and you'd still have a half. So this actually, half base times height, would also work. I did want to show that. All right, now to this one. This is 8. Oh, and then I better do this. Let's do like this angle. Get it away. Do this triangle far away from the other one. So what you got to do on this is you got to know that there's 6 of these triangles. And by the way, we can do these kind of questions on a triangle that's regular, a hexagon, and a square. Because what are all those angles on the inside for a square? Okay, 90. So you'd have a 45, 45, 90 relationship that you'd be able to do these things. All right, so 360 divided by 6 is 60. This is why this works well for, there's that touchscreen thing that crushes my ability to write with this pen as well. There's that 30 scratched down with my rotten pen. All right, so 30-degree side is 8. This is the 60-degree side. That's 8 root 3. And then that's all I really need. I don't even need the radius, which is 16 root 3. I have the apothem. I'm not even going to calculate all the way through. All right, and then the perimeter is 6 sides that are 16 each. There's my pen again. Love it. Love you, pen. Okay. All right, so 6 times, and then you can go ahead and calculate. I'm not here to teach you how to type the final answer on your calculator. All right, next. Just real quick, I'm going to fly through this one, but I'll take a breath for a second, let you write this down. And this is actually kind of interesting, but as you're writing this down, Maybe I'll randomly draw this triangle over here and understand you have 6 of them. What I should be doing, though, is also saying that these angles are bisected as you're writing this down. So we could find that whole angle measure from our interior angle formula, 180 times n minus 2 divided by n, and then cut that in half. And then we could get this corner right here. But it's a little bit easier to say that 360 divided by 6 is 60. So that when I drop this apothem down, then this is the 30. I could barely write that in there. So do understand that this is 12 here. And, all right, and that's the 90-degree side. So the 30-degree side is 6. The apothem then is 6 root 3. Again, those that did not lock that A root 3, 2a thing down, you're doomed, right? And it's up to you to get it figured out now at this point. It is interesting, in a hexagon, the radius does actually equal one of the sides. See that? 6 plus 6 is 12. So actually everything is good for this. I can move on to the trig ones, which is what you really need me for. But I really wanted to have a formal set of notes on the thing that I tried to kind of shove at you yesterday. There's 6 sides that are 12 units long for the perimeter. So half apothem times perimeter, and then you calculate. I'm done. Okay, you can type. And then again, remember, exact means leave the square root alone. Approximate means type the square root of 3 on your calculator times the other numbers. I have something later that shows that. All right, so again, you don't really need a calculator nor trig for a regular triangle, square, or hexagon. Very specific. Three types give you 30, 60, 90s, 60, 30, 90s, or 45, 45, 90s. Well, now we don't have that. So let's zoom in at one at a time here. Very tough to draw when you have to make your own notes. And that does say up here, find the area, round to the nearest 10th. I think I went against that first hour. And I will get my calculator ready. So hit freeze. Remind me that I'm frozen. Let it go. And then as you're drawing this, it's probably hard to look up there, right? But then when you have the drawing, it's not hard to figure out how many sides there are. I'm still waiting for the calculator to open. Okay, finally did it. Okay, and then I gotta put it down there. So I do want to show you some things I can do in my calculator to not round until the end. And that is a rule that you should go by there. Do not round. So when I have the drawing, I could do this. And it says it's regular up there. So 1, 2, this is how I count. I actually mark when I count. 1, 2, 3, 4, 5, 6, 7. Okay, I got 7 sides. When there's more sides, it's harder. It's a lot harder. The more sides, it almost looks like a circle. So you have to really make sure you see those little corners there. All right, but that's 7-sided. So if I do half apothem times perimeter, half apothem times perimeter, it's 7 times 2 is the perimeter. At least I got that started. All right, so I had to find out how many sides are, which is 14, but I just wanted to make a point. Next thing is much easier to say to yourself, okay, what's that angle measure right there? 360 divided by 7, which is the first thing I'm going to do in my calculator. 360 divided by 7. I wonder when I did all that. That's weird because I didn't think I had my calculator open yesterday. I'm going to go ahead and mark that, 51.4, but I'm going to leave it on my calculator. Because then to draw this one, which is I'm going to get into the apothem and this radius, it's going to be really hard to draw. Divide that by 2 because that's exactly what the apothem does. 25.7 approximately. Notice I have not rounded yet because I keep using the same pen. I love it. I love you. All right, but that's 25.7 degrees in there. Okay? So now another thing that this does is it bisects. By the way, did anyone do the trig questions already on your worksheet? All right, you just figured it out. Yeah, good, good, good. Did you do it during my notes when you weren't listening? Anyway. Ooh, that was a dirty look. I should have showed that picture of the student just looking at me like that. Julie, right? Yeah. Good. Thumbs up. All right. Okay, so I have to find the apothem. So we're going to call this X. This is what I got to find. All right, guys. What side is this? Opposite, adjacent, or hypotenuse? 3, 2, 1, go. Opposite. What side is this? 3, 2, 1, go. Adjacent. What deals with opposite and adjacent? Tan or TOA. So you take tan of this angle measure. Oh, I looked at the wrong thing. Tan of 25.7, but watch how I write this. Nice pen. Dot, 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 dot. That's supposed to be a bunch of dots, but my pen just stinks now. It's even worse than it's ever been, which seems impossible. Heard people are talking about me in tutoring. He only just complains about his pen. All right, anyway, and then remember, do you remember? Get tricky with it. Da-da-da-da-da-da. These two just switch, all right? So X actually equals. I don't complain about my pen that much. Only every single time it screws up, which is 25 times during the notes, every single day for 5 sets of notes during the day. Do you see why I'm going crazy? All right, anyway, let's go to this. 1, watch how I handle this, divided by tan. By the way, what should I make sure I'm in? What should I make sure I'm in? Radians. I'm sorry, not radians. Degrees. Big save there. Enter. By the way, you get like a big giveaway was you get a negative answer. There's no way you should get a negative answer on a geometry type question. So anyway, second quit. And then watch how I grab this. Enter. I screwed up. Did you hear Yoda just laugh too? That was my phone. By the way, speaking of that, wait till you see this next one. Actually, what I could have done is something different. I could have done the ANS button. Second, previous answer. Now what I have is an unrounded answer. Right? So 2.07 blah goes in this thing. 2.07 blah. That just means I'm not going to round still. Then I could do 0.5. Come on, calculator. 0.5 times answer. This is a rule, especially if you're going to be like an engineer. You don't round until the end. And then I forgot, what was our perimeter? 2 times 14, 2 times 7, which is 14. Okay, times 14. So I have not rounded yet until the end. And now I can write 14.5. It did say round to the nearest tenth. 14.5 units squared. Wait, no, wrong, feet. I'll just write it like this because that's how my pen looks like anyway when I'm trying to write anything in normal. Okay, and then I'm not going to do all of this one. We're going to move on to our PowerPoints. Perimeter is 20. It's a pentagon. So let's get it over with. Each side is 4. Next thing, it's a pentagon. Whoops. Well, that was the touchscreen kicking in, which that feature needs to be turned off, but I can't. So what is that angle measure? That is 360 divided by 5, which I believe is 72. Is that right? Good. I see people hitting some buttons. So if I actually wanted to construct the apothem, I know that this would be 36. Half of. So now I got it, and it's the same thing. This is 10. This is x. Which trig function would it be again? To find x. Tan. Okay, so we got it. And I'm not going to do that. It makes the point. Quick question? Oh, it's not 10. I'm a liar and a bum. I looked at the perimeter as 20, and I took half of that. Sorry, each side is 4. So actually that is a 2. All right, half of 4. Okay? All right. I don't know how this is going to work because I'm in the middle of a video. I think it should be fine that it shows these. Don't take this one down. This is Mickey Mouse, but I'm just doing this for for comical relief for Samulus of old. Display settings. Let me try to do duplicate slideshow. There we go. I like this. Okay, hide that. Oh, what just happened? What just happened? Did I just close that? Oh, is it here? Okay. And I think this goes. Did you hear that? Okay, so when I made this PowerPoint, I put a bunch of Star Wars sounds. Okay, so a circle. Did you hear that? What was that a sound of? Lightsaber. Nice. So what would the area of this be? Tell me in words. Square. What? Minus circle. Okay, so just listen for. What's that a sound of? Huh? That's a TIE. That's a TIE fighter. All right. Find the area of the shaded region. When I'm giving you 8 here, the area of the circle would be 8 squared times pi. And then what's the length of the square? How long is the square then? What's each side measure? 3, 2, 1, go. 16. No, that's not Star Wars. Oh, we can't do that. What was that? Lightsaber. Another lightsaber. I have you now. I don't know if they can hear this on the thing because it's over there. Right? Good stuff. Ooh. Now, take note. Exact, approximate. Okay, then this is funny. I actually had this happen with Mr. Stronowski. Noticed this right away. When I start this one, what actually does that look like as a picture? Hold on. What did I do here? Nope, I want that. Okay, there we go. What does that look like? Mr. Stronowski said this looks like this immediately. It looks like a TIE fighter. Nice, Caleb. I should go ahead and get a drink and then leave it right there. Take a walk, get a drink. Hurry up. We got no time. That's a reward. Make as much noise as you want. Look at it. Everyone sit. There it is, everyone. All right. Okay, now sit down and leave it right there. Okay, so what are we going to do here? It's going to be hexagon minus rectangle plus circle. Okay, so this is what I have for a worksheet for you next. I'm only going to give you one piece of information. All right, so now this one maybe write down. I'll go slower. No Star Wars sounds. I actually didn't even play that one yesterday. I was just messing around last hour. I'm like, oh my gosh. Now I kind of remember making this, and I actually have all those Star Wars sounds saved on my computer. Actually, my computer from the late 90s, when I would open it up, when I press start, it would be Yoda. I am wondering, why are you here? Every time that I opened up the computer. Then anytime I get a email, I think it would be a Chewbacca. Roar! Like that one video when I taught, like Chewbacca. Yeah, it was a whole bunch of sounds. I'm just stalling so they have a chance to write this drawing. So draw the hexagon first. Next thing is I connect these vertices and just kind of shade, maybe use some highlighting. And then after that, try to get, right at the middle points here. Try to draw a nice little circle and shade that in for your own notes. So you have a regular hexagon, you have a rectangle, and then a circle is always, circle is, I wasn't going to say regular, but all circles have, very confined properties. You'll be fine. Just put a 12 if you think I'm going too fast. It's just what I do is I break them all down there. So if that's 12, then that's 12, right? On the rectangle. And then I kind of am in the way, but see, it always messes that up. So let's see if I can get back to that. Okay, that's fine. So then what it also tells me is I know the perimeter for sure. And you can put this in any way, shape, or form. But doing a PowerPoint, I have slides, and I have to break down each thing separately. Your notes are certainly going to be way less. You're not going to keep doing the drawings. You don't have to separate all the drawings, I don't think. But I think you also know that we have enough information for the circle, but not the rectangle yet. You're missing the if you call this the width, you're missing the length. So we got to hold off on that for a second. All right, but you definitely have information about the circle. You have the diameter. That circle's stuck right in there, from end to end, equal to the 12 up above there. So since you have 12 there, that's going to be 6 for a radius. So the only thing I could find right now is the circle's area. I got to do what I just showed you, how to find the area of a hexagon first. So establish a plan. We got a 12 there. So we have to find the apothem. I'm barely in the way there. I think I'm fine. Okay, so we have to find the apothem. We just did that. So what you got to do is draw the center. Draw a radius. You can do this within your original drawing that was given. And then draw an apothem. Or, okay, knowing that that's 60, yet again, this is why hexagons are great to do these area questions for. Because then when I draw the apothem, yet again, this is 30. So you get another representation of what I showed you earlier. So you have a little 30, 60, 90 there. And then also the bisection thing. So that is 6 right here. 6 plus 6 is 12. That's the 30-degree side. I need the 60-degree side, which is 6 times the, say it, root 3. Here it comes, flying in. So the apothem 6 root 3. But this actually tells you something else. This randomly, again, this is going to go to another slide, tells you that length, I guess I called the width 12, this length is a 6 root 3 and another 6 root 3 because these apothems are equal. So now that is 12 root 3. So finding the apothem also was able to find me the length of the rectangle. So area of a hexagon is, and then you could break this down any way you want. I broke these down all individually and then do the final answer at the end. You write it any way that you want. So it's half apothem, half of 6 root 3 times 12 times 6, which I already calculated as 72. Just hold that number and then just go ahead and write your final answer with all the other ones. But I'll show you that on the other page. Okay, and then area of the rectangle is 12 times 12 root 3, length times width. And then don't overdo it on the end, unless you really do want to break this down like this. It's not the final answer. I should not have circled there. So I'm in the way again. I'll move myself. That was ultimately the what we wanted to do there. I guess I can get rid of myself here. Boom. So as said on the other one, it was hexagon minus rectangle plus circle. All right. So should have put all that work in there on that page as well, knowing how this breaks down. And I should not have circled the previous page. Okay, and then know the difference between exact and approximate. So 216 root 3 minus 144 root 3 is a like term situation. 216 minus 144 is 72 root 3. But then plus 6 squared pi, 36 pi, that is, those can't be combined. So to write this in exact form is to write it like an expression with 2 different variables. Right? And then to calculate it, you just type it as is on your calculator. So again, half apothem times perimeter. I wish I would have carried over those drawings with some of those markings on there, but you should have marked it as you've gone. I just didn't want to mess up the circle. I wanted to circle out of there as I was calculating the area of the hexagon, and then randomly getting the length of the rectangle from the apothems. Okay, all right, so I'll shut down the video. I think I don't know if I can now that I stuck here. I guess I could freeze the screen for you guys and then delete this for those that are finishing up writing. Good, yep, that worked. And here comes your worksheet.